So, hello students, a very good morning to all. And yes, I'm back with some new important topics for prelims of 4th April. So, please focus on the topics which I am discussing because at least one prelims question can be asked from all these topics. So, no, there are news related to Aditya L1, news related to nuclear fission and fusion. So, all these topics are very important from prelims point of view. So, let's start our discussion. So these are the three important topics which we shall be discussing today. So our first topic is about the nuclear fusion. So whenever we discuss nuclear fusion, then we shall be discussing the difference also between nuclear fission and fusion. After that, Aditya L1 mission. And next topic is about INS Aridhaman. So it was a big victory for India because it was recently commissioned. So we shall be discussing this also. Now, our first topic is about the nuclear fusion. So, here the context is that earlier the scientists used to think that whenever a new technology is developed, okay. So whenever we develop a new technology, so when this technology is becoming in more and more use, then its economy of scale increases and hence the cost of that technology reduces. So this is the main conception which till now the people have, that if we are talking about the nuclear fusion, so once we develop this technology completely, this nuclear fusion technology, then if we start increasing its use more and more, then over a period of time its cost overall will reduce. But according to recent news, the recent news says that this thing might be overhyped because this technology is very difficult to produce in the full scale in a complete manner. So even if we develop this technology, you cannot reduce its cost. So scientists are overestimating it. Now briefly let's discuss about the nuclear fusion. So the process of nuclear fusion basically takes in sun and stars, and this all overall process we are trying to replicate on Earth. Second important thing about this is this involves the fusion of two lighter nuclei. For example, uh, two lighter nuclei we can talk about deuterium, and second we can talk about tritium. So deuterium and tritium both are the isotopes of hydrogen, and when we combine deuterium and tritium, so we get the nucleus of helium, and a remaining energy gets converted into heat, and finally we use this heat to produce electricity. So this is the overall process of fusion. The advantage of nuclear fusion technology is no long-lived waste is produced. As we have seen in the nuclear, when we conduct the fission reaction, nuclear fission reactors. So long-lived waste is produced, as we have seen in the Fukushima Daiichi nuclear disaster or Chernobyl nuclear disaster. Now, briefly, let's discuss how this overall process works, the complete step-by-step process. So first of all, what will happen? First comes the fuel. So here fuel we will be using deuterium. Just a second. So here fuel we will be using will be deuterium and tritium, which I have already said. So first, what will be the first stage? Here they will be converted into a plasma state. So plasma is considered the fourth state of matter. So how they will be converted into plasma state? They will be converted, they will be subjected to very high temperature. So very high temperature, so that, for example, this is nucleus of any atom and these are the electrons revolving around the nucleus. So the temperature is very high so that these electrons will lose the attraction from the nucleus, so that the temperature is very high. Now since they are converted into the plasma state at very high temperature, now what will happen? These nuclei of deuterium and tritium, they will be moved at very high kinetic energy or very high speed. Why we are doing that? Because since deuterium is also positively charged, tritium is also positively charged, and as you know, the same charged particles will repel each other, but we want to fuse them. So here comes the second stage. So we will move them at very high kinetic energy. And why we are doing this? So that they can overcome the repulsive force, the electrostatic repulsion, because positive will repel and we want to fuse them. So because of that, we need a very high kinetic energy so that they can fuse together. Now, after they fuse, so deuterium and tritium, they will combine, and after combination they will produce the nuclei of helium. Now the mass of helium will be a bit less than the combined mass of deuterium and tritium. So where is the remaining mass gone? This remaining mass got converted in the form of energy. So this is the Einstein's equation, E equal to mc square. So here this m is the mass, which is the remaining mass. So deuterium plus tritium provides helium and the remaining mass gets converted into form of energy, and this energy only we are using to produce steam, to produce heat, and that heat will produce steam. This steam will drive the turbines, and driving the turbines will produce the electricity. So this is the overall process how a nuclear fusion reaction works. And because of this only, scientists are saying that since generating the state of plasma is very difficult, overcoming electrostatic force of repulsion is also very difficult. That means this overall technology is very costly. So over a period of time also, if you start using this technology, the cost will not reduce. Now, here, since we have discussed about the nuclear fusion, so let's discuss briefly about the nuclear fusion also, and then we will be discussing the important point of difference. So here, fusion, we already discussed that fusion, you will combine two small nuclei, here deuterium and tritium we did. So here fusion will take place, and after fusion took place, helium will be generated. Mass of helium will be a bit less than the combined mass of these two nuclei, so the remaining mass will be converted in the form of energy. Now, if we talk about the fission reaction, so in fission reaction, a bigger nuclei will be split into two or more than two nuclei. So, for example, here a bigger nuclei can be of uranium or plutonium, and then it will be dissociated into two or three other nuclei. So, here energy is converted into in this form. Now, briefly, let's discuss the basic point of differences between nuclear fission as well as nuclear fusion as well as nuclear fission. So, process we already discussed here. Two lighter nuclei are joined, and here a bigger nuclei will be splitted. If we talk about fuel, so here mainly the isotopes of hydrogen are used. That means deuterium and tritium. But here heavy elements like uranium and plutonium is used. If we talk about the release of energy, so release of energy is very high in nuclear fusion, significantly higher per unit of mass. So this question can be asked in prelims, that energy produced in fusion reaction is more, or energy produced in nuclear fission reaction is more. So this is very important. Very high energy is produced in nuclear fusion reaction. Now, if we talk about the waste, so important thing here is no long-lived nuclear waste is produced, and helium is the byproduct. But if we talk about the fission reaction, so the nuclear waste remains in the environment for longer period of time, and this was seen in the Chernobyl, after Chernobyl nuclear disaster. If we talk about the risk, so here is no risk of meltdown. Risk of meltdown will happen only if there is a continuous chain reaction, means you are not able to control the reaction, and hence because of the high amount of heat generated, your nuclear reactor can melt down. This cannot happen here. Why it cannot happen? Because the conditions required to start this nuclear fusion reaction is very difficult. So how automatically it can lead to chain reaction? But this thing is opposite in nuclear fission reaction. The reason for this is nuclear fission reaction uses the fissile material, and if you are not controlling it, it will go on splitting and it will go on increasing the chain reaction. Now, what is the current status of this energy? So, as we already know, if we talk about nuclear fusion, so it is still under the experimental state. But nuclear fission is widely used. India also no use nuclear energy for civilian purposes. When we talk about the recent West Asia conflict, so this is the main point of contention, because Iran is enriched in uranium, and uranium is the main fuel in the nuclear fission. So these are some of the important points. Now, briefly, let's discuss about the advantages of nuclear fusion. So first important thing is the abundant energy. I think we already discussed that output is very, very high as compared to nuclear fission. Second important thing, and this thing is very, very important for prelims, that it do not produce any greenhouse gas emissions. So we can say it is clean source of energy. Very, very important, because these kind of extreme words are used in prelims to confuse. So maybe if there is a statement that it produce very low amount of greenhouse gas emissions, then we can say that maybe it is correct. But if somewhere this extreme word of no or never is used, we generally get confused. So you have to remember this: no greenhouse gas emission is produced under the nuclear fusion reaction. Next is no long-lived waste. So this we have already discussed when we were discussing the difference. Since no long-lived waste is there, then there is no harm to the environment also. And next is the limited proliferation risk. What is the sense of this? Because since the conditions to achieve the nuclear fusion are very, very difficult to create, and hence there is no meaning of nuclear proliferation. Now, let's discuss briefly about the limitations of nuclear fusion. So, first limitation is about the extreme complexity. See, this we discussed under the advantages also. But what we discussed, that since the all the conditions are very difficult to achieve, and hence it cannot lead to nuclear meltdown. But it is disadvantage also, because since the conditions are very difficult to achieve, and hence the system is very complex, it is very difficult to build the nuclear reactor based on fusion. Second thing is about the energy requirements. See, here we discussed all the process, that or what all things are required to start a nuclear fusion. So first you have to convert in the plasma state, then you have to move the nuclei under the very high kinetic energy, etc., etc. So all these things require a lot of energy, requires a lot of electricity. So it is also a very big challenge. Next thing is about the structural rigidity. That means no, it's kind of the layers of onion. That means every layer is dependent on every other layer. So if there is small change in one component, then you have to change the entire design. And next thing is the lack of mass production. That means, for example, this is place A and this is place B. For example, place A is prone to earthquakes. So here, if you are building a nuclear reactor, then you have to change the design, because you have to incorporate the seismic vulnerabilities also. But this thing you may not need to do in place B. So this is the reason you cannot do the mass production, because you have to customize the design of nuclear reactor based on any place. Okay, so next topic is about the Aditya L1 mission. So this topic is also very, very important for prelims. So what is the context here? That as we know that Aditya mission has already been placed in at the Lagrange point, that is L1. So now ISRO has invited researchers to utilize this data through second announcement of opportunity cycle. Announcement of opportunity cycle is meaning that any agency, for example, ISRO or NASA, will inform all the researchers, all the experts, that they can use the data from a particular mission to conduct the experiments, to build the instruments, or to analyze the data. So, this is the meaning of announcement of opportunity. So let's briefly discuss some important points about Aditya L1, prelims related points. So first important thing is it was launched by ISRO using PSLV. So this is the first important thing because you may get confused in GSLV and PSLV. So GSLV related to geostationary, PSLV is the polar satellite mainly related to low Earth orbit or medium Earth orbit. Next important thing is that Aditya L1 spacecraft will be inserted into a halo orbit. We will be discussing what is halo orbit around L1 point. So these two things are very important. What is halo orbit and what is L1 point? Next important thing is it will collect data for 5 years by continuously observing the sun. So Aditya L1 mission was launched in 2023 and in 2024 finally it was placed at L1 point where it was supposed to be placed. Now for next 5 years it will study the overall atmosphere of sun. Next important thing is this makes ISRO the third agency after NASA and European Space Agency to place an observatory at L1 point. So, how many countries have done this? NASA, European, how many agencies have done this? So, NASA, European Space Agency, as well as India. Let's discuss about the objectives of Aditya L1 mission. Why we are conducting this mission. So main objective of this mission is to study the solar atmosphere, which includes the corona, chromosphere and photosphere. So here you can see the picture. So this is this outermost layer of sun is the corona, and then we have chromosphere, and here we have photosphere. So the top three layers of the sun, Aditya L1 mission has to study. And what it will study, it will examine the solar emissions, including solar winds, flares, etc., etc. And what is the impact of all these phenomena on the space weather. Now, why Aditya L1 mission is doing these things? Why do we need to study the sun or the atmosphere of the sun or the phenomena related to sun? What is the sense of this? So first important thing is about the evolution of planet, that is Earth. So as we know that sun is the main planet and sun drives the evolution of overall planets. So based on the study of atmosphere of the sun, we can predict the changes which can happen on the Earth atmosphere or Earth surface. Next thing is about the solar weather impact. See, as we know, because of the solar weather, our satellites can be impacted. Our satellites can change, or our satellites can be damaged, or our satellites can change their orbit. So, because of that, it's very important to study the space weather about the coronal mass ejections, about the solar wind, solar flares, etc. Next important thing is if we want to study the solar phenomena, then people can say then that you can create the simulation in the lab and you can study here only. Why we are sending a mission on the no especially on the sun, especially at the Lagrange point? So reason for this is most of the conditions related to solar atmosphere cannot be replicated on the earth, and hence specially we have to send the solar mission, that is Aditya L1 mission. Next important thing is if even if we want to study all these things on earth, so the atmosphere of earth will block the UV radiations, we know this. And if UV radiations are blocked, which layer of this atmosphere does that? It is stratosphere. So if UV radiations are blocked by the earth, then we cannot study the completely the the solar atmosphere. So because of all these things, Aditya mission L1 mission was included. Now, briefly, let's discuss about the Lagrange point because this topic is very important for the prelims. So, first of all, let's know the definition. What is Lagrange point? So, Lagrange point is any point in the space where the gravitational forces of two bodies are balanced so that that particular object remains in its orbit. Now, I will explain here that it is a point in space where gravitational forces of two large bodies, that is this is sun and this is earth. So here at L1 gravitational forces of these two bodies are balanced and the object will experience overall no force. So this is the meaning for this. So here for any celestial bodies there are five Lagrange points. So if I talk about the earth, so here are five Lagrange points. This is L1, L2, L3, L4 and L5. So at all the points, if any object is placed at all the points, so the gravitational forces of the two bodies will balance so that it can remain in its orbit. Now let's discuss the basic things about all these 5 points. Now, why L1 point was chosen for Aditya mission? It is chosen because if we are placing our mission at L1, then we can easily study the sun, because we can easily see the sun because it is present between sun and earth only. That's why L1 point was chosen. Why we have not chosen L3? Because L3 is located no on other side of the sun, so we cannot study that easily. If we are talking about L2, so L2 is basically used to study the overall things in the space, because L2 does not have the direct line of sight for the sun. So these are points L1, L2, L3. Now, other important point is, see, as we know, L1, L2, L3 points are in the same line. These points are called the unstable points. Unstable points means here, if any object is placed around these 3 points, then they need to be balanced by gravitational forces of two bodies, because if they are not balanced, the object can move in any other place in the space. But this thing is not possible. This thing cannot happen for L4 and L5, because L4 and L5 are considered as the stable points. That means if any object is revolving around the L4, no, it will remain in its orbit. It does not need any balancing due to gravitational force. So these are some of the important points. Now about the halo orbit. So halo orbit is nothing but the orbit around the Lagrange point. So if we are talking about the L1, so this is the halo orbit of L1. So here Aditya L1 mission will be revolving around this. Now, briefly, let's summarize what all we discussed. So, first of all, if we are talking about the objective, so the objective is to study the sun's atmosphere, and this mission was brought by ISRO. Here are the main payloads under the Aditya L1 mission, because in UPSC Mains 2023, the question was asked on the payloads of Chandrayaan 3 mission. So maybe UPSC sometime can ask the payloads of Aditya L1 mission also. Then we already discussed it was launched in 2023, and uh, multiple orbits around Earth. See, what is the meaning for this? See, this is Earth, this is orbit of the Earth, and this is Lagrange point L1. So it's not like the spacecraft will start from Earth and it will directly go on the Lagrange point. It will start rotations around the Earth, it will do rotations, and finally it will be parked in L1 orbit. So this is the meaning of multiple orbits around the Earth. So in this way, it was parked in L1 orbit. Now, what are the main operations? So, continuous observations of the sun. And what data will be collected? Data related to solar flares, coronal heating, etc., etc. So, these were the some important points. Okay, so quickly, let's discuss some of the important points related to INS Aridhaman. So, first important thing here is INS Aridhaman is India's third indigenously built SSBN, that means nuclear powered ballistic missile submarine. So, first important point is that it is indigenously built. Second important point is it is part of Arihant class nuclear submarines. So, this is second important point. So, what is the use for this? It will enhance the India's nuclear capabilities and hence retaliatory capabilities. Who built it? So it was built under Advanced Technology Vessel Project. So what is Advanced Technology Vessel Project? Under this project, the nuclear powered ballistic missile submarines will be built, especially the Arihant class nuclear submarines. So this is this project, and it was built by shipbuilding center in Vishakhapatnam. Next important thing here is This submarine is 90% built from indigenous components. So first it is indigenously built, that is completely built in India, and in that also 90% parts used are also indigenous. Okay, now let's discuss some of the basics for nuclear powered submarine. So when we say nuclear powered submarine, powered ballistic missile submarine, so nuclear powered means it is powered by nuclear energy. And here nuclear energy is not nuclear fusion, it's nuclear fission. Nuclear powered ballistic missile submarine means this submarine can house numerous okay. So this submarine can consist of many number of ballistic missiles. So many missiles can be launched from the platform of this submarine. So this is the complete meaning of nuclear powered. And under this project, first submarine which was launched was INS Arihant, and it was launched in 2009. Second submarine was INS Arighat in 2024. And finally, in 2026, we have INS Aridhaman. Now, important thing is this is the first time India will have a minimum rotational fleet for continuous at sea deterrence. Meaning for this is if you want that every time 24/7 a particular submarine should be there for active patrolling in the seas, then for that you must have at least three submarines, because if one submarine is at active patrolling, other submarine may be would be under training, other submarine may be under the maintenance. So this can be done only if you have at least three submarines. If you have one or two submarines, then you cannot send the submarine for the active patrolling. So this is also important here. Next, let's discuss about some of the features of INS Aridhaman. So you don't need to remember all these features, all these specifications, just they were given in news, so I'm discussing. So first is about the displacement capacity. So it says that it can displace around 60,000 tons on the surface and 70,000 tons submerged. That means whenever any submarine is submerged under the water, then what amount of water it is displacing. So if displacement capacity is very high, that means that it can house many number of ballistic missiles. So this is very good. Second, it consists of pressurized water reactor of 83 megawatt. What is the purpose of pressurized water reactor? As we know that it is nuclear powered, so pressurized water reactor will ensure the nuclear reaction to generate the electricity. If we talk about the armaments, so it has four launch tubes. Launch tubes means the tubes from where the missiles will be launched from the submarine platform. And it also contains long range K4 missiles extending to 3500 km for intercontinental strikes. So these were some of the important things related to INS Aridhaman. Now a practice question for you. So, question is with reference to nuclear fusion, consider the following statements. First statement is nuclear fusion involves the splitting of heavy nuclei into lighter ones. Second is it is considered a potential source of clean energy. Third is its commercial viability is currently limited due to high cost and technological complexity. So now please read the question carefully and try to answer and give your answer in the comment section. Now, here homework for you. So first of all, you have to tell me atomic bomb is made using which technology and hydrogen bomb is made using which technology. Next thing you have to answer in the comment section is what is windfall tax. I am asking this because it was in news. Since it was a very small topic, that's why I haven't included in our discussion. So you just read the definition, just read the meaning of windfall tax, and it was in news in what context. And next you have to read about the Operation Chabutara. So it was also in news. It is also very small topic. That's why you just read what is the objective of Operation Chabutara. So these three things you have to search and you have to give the answer of practice question in the comment section. So that's all for the discussion from my side, and thank you. Have a nice day.